Hello everyone. So today we will be solving part number 2 of the same paper. We will start today from question number 11. In part number 1 we have done till question number 10. This is 0580 paper 2 extended 2023 May June paper. So question number 11 says, describe the single transformation that maps triangle A onto triangle B. As we can see, triangle B is the enlargement of triangle A. So triangle B is just the enlargement of triangle A. These two, and we can see here this is 1 and this is 2 blocks. So we can see here and we can write here that triangle A onto triangle B, it is called as enlargement. Then what is the scale factor of this enlargement? Scale factor, previously as I have told, it was 1 and this one is 2. So we can write scale factor is 2. Now we have to find the center for this enlargement. To find the center for this enlargement, we will take the ruler and then we will just take the center of these two triangles and then make the line that passes through the center, and also take from the other side now we can see that these two lines are joining here at this point. So the center of this enlargement is 0, 7. So this is the part A full solution. You'll be getting 1 marks for each of the answers because the total marks for this part is 3. So 1 for enlargement, 1 for the scale factor, and 1 for the center of the enlargement. Now coming to question number the 11 part number B. You can see from here with this figure and this figure. So we can see from here to here what's happening. It's rotating. And how much it is rotating? When you see this side is being coming to this side and the rotation is towards 90° clockwise. So I can write here B part. Say it is rotation. How much rotation? 90° rotation and clockwise rotation. Now we have to find the center of this rotation. Now to find the center of rotation, it's quite tricky. It's a bit tricky. What you can use, trial and error method. If I am taking this point, if I will take this point, let's say this point I am taking, join this point to this point and then this point to this point. Okay, so if you take these 2 points and just if I take this as a diagonal and this as a diagonal, it's not showing it. This is going up. This figure, you can see this is not exactly the same as this one. So we will remove this. Now coming to the other one, I'll make that line again which got erased. Yeah. So now for trial and error method for finding the center, I will take a point 3 and let's join this and then this point to this point. Now when I'm taking this, you can see if I will take this, this point if I will take, you can see this point is same as this point, both the diagonals. This is also 4 by 1, this is also 4 by 1. So my center of rotation is 3, this point you read 3, 1. It's a bit tricky. The other way you can do this one by using the tracing paper while solving this. Now, coming to question number 12. In this figure, in a circle, ABC are the points on the circumference of the circle. O is the center of the circle. AO, OB and OC are the radii of the circle. AB is given as equals to BC. Therefore, triangle AOB is congruent to triangle COB. Draw a ring around the correct criteria for this statement. So we can, as we can see here, since in this triangle and this triangle, we can see that AO is also equals to OC because these two both are radius. So I can write here that this side is equals to this side and OB is a common side in both the triangles. So using this statement that AO is equals to OC, AB is equals to BC and BO is equals to BO, common in both. We can say that by side rule, these two triangles are congruent. Part number B. P, Q, R and S are points on a circle and TQU is a tangent to the circle at point Q. P, R and SQ intersect at the center of the circle O and PQ is parallel to SR. Angle RQU is 42 degree. Calculate angle QSR. So QSR, if you can see that this angle is 42, so angle QSR will also be 42 by alternate segment theorem of the circle theorem. So you can write it here that QSR is equals to 42 degree. And what is the reason? Alternate segment theorem. Now you second part, you have to find angle PQS, this angle. Since given SR and PQ both are parallel to each other and SQ is the transverse line passing through these two parallel lines, when two lines are parallel and a third line cutting them, then this is the law, this is the theorem that this angle is equals to this angle and they are called as alternate angles. So you're seeing this figure, we can say that this angle is also equals to 42 degree and the reason is alternate angles. Now part number 3, angle POS. This angle we have to find. POS. So POS is equals to what? POS will be equal to, we use one more theorem of the circle theorem, that angle subtended at the center is twice of the angle subtended at the circumference. So if this angle is 42 degree, this angle is 42 degree, so angle at the center will be twice of this angle. So POS will be twice of 42, which is equals to 84 degrees. Why? Angle at center is twice of angle at circumference.